All right, we're going to be looking at lesson 7.5, and what we're going to do is we're going to be graphing exponential functions. So in other words, we're actually going to take a look at a graph of what some of these things would look like that we've been working with the last few days. And then we're also going to take a look at how do we use our calculators to do order of operations, given usually in the form of a word problem. All right, so an exponential function is a function that can be described by an equation in the form of y equals a to the x, okay? And a is just going to be a number, guys. Y and x will be left alone. Where a has to be bigger than 0, so we don't want any negatives here. And it also cannot be equal to 1, because 1 to any exponent will just be itself, so it's hard to get a graph if it's all just ones. Okay, there's going to be two specific types of graphs we're going to look at. We're going to look at a growth and a decay, okay? So we have an initial amount that increases by the same percent over a given period of time. And then for decay, it's when our initial amount decreases by the same percent over a given period of time. All right, so let's take a look here. The directions here say graph each function, find the y-intercept, and state the domain and range, okay? So the first thing we're going to do is we're going to take a look at just this guy, and we're going to have to make a table. There is no other way to graph these than by making a table, okay? And we're all going to be using the same numbers. So we're going to have our y and our x, and down our x column we're going to do -2, -1, 0, 1, and 2. Very similar to how we graphed lines. But when we did lines together, we just did the -2, the 0, and the 2. All right, and so what we're going to do is then we're going to take these guys here, and we are going to plug it in for the x right there. All right, so if I do the first one here, that would be 2 to the -2 power. Okay, well, again, keep in mind, you can use a calculator or just remember that that's going to drop down to the bottom, right? So it's going to be 1/4. Then you're going to have 2 to the -1 power. Again, that negative drops it, and it becomes 1/2. 2 to the 0, well, anything raised to 0 power is 1. 2 to the first would be 2, and then 2 squared would be 4. Okay, so now I know this graph's not the best to tell here, but here, right here is your origin. I'm trying to mark it here for you. Okay, so now if I want to graph, so start with your first one here, -2 and 1/4. Okay, so -2 and 1/4 is going to be just above that line right there. Okay, and then -1/2, so go to the halfway point. It's going to, okay, so now I'm going to draw arrows on both ends, and it is going to be a curve. And if I'm looking at this, as I'm coming across here, it's going farther and farther up and up and up and up and up. So this would be a growth. This would be an example of a growth. Okay. All right, so now let's take a look at some of the other things we need to get here. Okay, the y-intercept. Okay, so the y-intercept, where does it cross the y-axis? Now, the nice thing about this is it is always going to be in our table right here. Okay, so 0, 1 is our y-intercept. So over here, y-intercept is going to be 0, 1. Okay, on the domain, we're talking about all of our x values. Okay, so domain, x values, and what x values have been graphed. And our range, we're going to talk about our y values. And what y values will be graphed. Okay, so now on our domain, if I go back and look at my picture here, on the x's, so if I look across, okay, so x's go across this way, what points will be graphed? Well, if I look at this arrow means it's going to go forever this way. So everything here has been graphed. All these x's have been covered. And then right here, we kind of get to this point where we're not sure, does it keep going? Does it shoot right up? What's going on? While this does shoot up, it is still going to continue to go out as well. Okay? So when I'm looking at my x values, everything on the x-axis will always get graphed at some point. Even if it doesn't show up on our picture, if we were to keep it going, it would show up. So for these problems, when we're asking domain, okay, what x values have been graphed, it's almost always going to be all reals. Okay, now let's look at the y values or our range. So let's go back over to our picture. Okay, now on our range, it's our y values. Okay, so while if I think about how this is covered all up here, everything up here is good, and then we kind of hit a point where, man, we're coming down, but do we ever drop into the negatives? What happens right here? Okay, so now just so you know, these fractions will continue to get closer and closer and closer and closer and closer to 0, but it will never actually touch whatever line we're coming up on as it what we say approaches, okay? So it's never actually going to touch 0. It's going to get really close to 0, but it's never going to actually touch 0. And all the graphs will be the same way. They're going to come down, and then eventually they'll kind of level off for you. So if I'm looking here, what I'm going to write for my y values is going to be everything bigger than 0. Okay? All right, so let's try this again. All right, so now this guy, we're still going to make a table. Okay, so we're going to make our table here. So we have got x, y, -2, -1, 0, 1, and 2. Okay, now we do have a typo here. Okay, this guy right here should have been a fraction bar all the way across. It should just be 1/3 of the x. It's not a negative sign. Okay, so that should have been 1/3, just to make sure everybody's clear on that. Okay, so now if I do -1/3, or sorry, 1/3 to the -2 power, remember that -2, we just drop it in, but then we also have to flip. So it's going to become 3 squared over 1 squared, or 9. Again, you can just stick these in your calculator if you need to. 1/3 to the -1 power flips, becomes 3. Anything to the 0 power is 1. 1/3 to the first would just be 1/3. And 1/3 squared, 1 squared is 1, 3 squared is 9. Okay? All right, so now let's go ahead and start graphing. Again, I'm going to go ahead and mark the origin just so you can kind of see it here. Okay, so -2, 9 would be way up here. This is where the 9's at. -1, 1, 2, 3, 0, 1, and then we got 1, 1/3. Again, just estimate the best you can. And 2, 1/8, 1/9. Okay? All right, so now we're going to draw a line coming down, and it should, again, kind of flatten out here. Okay? All right, so now the first thing we're looking for is our intercept. Again, you can look at your graph right here, or it'll always be in your table, and it's not always going to be 0, 1. Please take note of that. Okay? So I've got 0, 1. Okay, domain and range. Keep in mind, domain is your x values. Okay, so what x values get graphed? Well, again, everything over here, because that arrow means everything's going here. And this guy, while it's not the best graph, is going to keep opening up, and go out, out, out. So all reals. And then if we're going ahead and looking at our domain, sorry, our range, our y values, notice how we're coming up along this origin, x-axis. So we're coming up close to 0 again, but we're never going to cross that. Okay, so when I come over here, my domain, again, is going to be all reals. And my y value for this particular problem, again, this is not going to be true for all problems, it's going to stay up above 0. So y is greater than 0. All right, let's go ahead and go to the next page. Okay, so on this, what we're going to be looking at, it says determine whether it's exponential, yes or no, and explain. Okay, now you have 2 methods to get this job done here. All right, so the first one is just a graph. Make a picture, see if it looks like it's exponential. Okay, method 2 is look at the y values. So focus on your y values and see if you are multiplying or dividing by the same unit or same number. Okay, so it has to happen all the way across. Okay, it can't just be one part or the other. Okay, so if I look at this, one of the things we still have to focus on is that x, and make sure that x is just the same unit apart. Okay, so like here, when I'm going from here to here, I'm adding 2. If not, that could change your answer. Okay, so in this case, oh, I said 2, didn't I? Adding 1. Okay, now on the bottom, I'm kind of looking to see what's going on here. Well, to go to 9 to 12, I would actually add 3, add 3, add 3. So is this exponential? No, because it's not multiplication or division. If I were to graph this out, this is actually going to give me a line. Lines have addition and subtraction in it. Exponential will be multiplication and division. So when I write my answer here, it's going to be no. And then you're going to talk about how this is a linear or makes a line. Okay, this is a linear function. So if it adds or subtracts the same amount all the way through, that's linear. Okay? All right, so now let's look at this guy. So again, double check your tops. Add 5, add 5, add 5. So our tops are looking good. Now check your bottoms. Okay, you could say, yeah, I'm minusing 10, but then I don't minus 10 here. So think of something else. Divide by 2, divide by 2, divide by 2, because just so you know, this is saying 2.5, just in case you can't read that. So if I'm looking here to here, I'm dividing by 2 or multiplying by half, same thing. So it doesn't matter if it's multiplication or division, just as long as you're doing that. So yes, this is exponential. The y values are being divided by 2 each time. Okay? All right, so that's the difference between linear and exponential, okay? So linear, we're going to be adding or subtracting. Exponential, multiply or divide. Again, if you want to do a graph, you would do a graph here and it'd give you a nice pretty line. Or if you did a graph here, it would give you that curve we were just kind of looking at, okay? All right, and our last problem here. If you don't have a calculator, you're going to need to go ahead and get your calculator out because I'm going to talk to you about how to plug something like this into your calculator. Okay, so the value of a Royce Company computer equipment is decreasing in value according to the following function. So this is the equation they've given us. X is the number of years that have elapsed since the equipment was purchased, and Y is the dollar. What was the value 5 years after it was purchased? Round your answer to the nearest cent. So that would be 2 decimal places. Okay? So now I've got to figure out, where does this 5 go? Well, if I'm thinking about 5 years and I come back here and say X is the number of years, I better plug 5 in right there. So I'm going to find out the value, that's the Y, 4,000 times 0.87 to the 5th power. Okay? So now, for most of you, you've got your calculator. I want you actually to type in 4,000, do your parenthesis, 0.87, and then do your exponent, okay? So you'll either have to do your caret. So remember, we're either looking for the caret or we're looking that y to the x button. So look for one of those two buttons and then put 5 up there. Okay, so when you do it, you should end up with $1,993.68 rounded off correctly. Okay, so double check that you can get that into your calculator, and if you can, you're good. If not, talk to me tomorrow so we can figure out what you're doing wrong. Okay, and that concludes today's notes. Please attempt the on your own problems now.